All right, good morning. So today we're going to go over page 2 of the Chapter 2 note page for Integrated Math 2. Question number 7 says, label the triangles so that they are congruent. All right, so I'm going to use green right now. Green shows up really well. So I'm going to, if these two triangles are congruent by side, I'm going to match, or I'm going to give a single tick and a single tick on those two sides, and a double tick and a double tick on those two sides. No, it's a little bit long. And the shared side right here, I'm just going to put a triple tick. 2, 3. All right, so now they're congruent by side. All right, this one, they want us to mark congruent by side, angle side. So I'm going to mark this side congruent to this side, and then the angle is in between. So I'm going to use this angle right here and this angle right here, which happen to be vertical angles, and they are congruent. And then the S comes right after, so this side, double tick, and this side, double tick. All right. All right, right here we've got angle side. So I'm going to mark this angle, and then this corresponding angle right here, and then the following angle. So I can either go this direction or this direction. So I'm going to go this direction and do a double arc. So from here, I'm going to go this direction to a double arc. The S, or the side, comes after. So angle, side. Angle, side. All right. This one is angle, side, angle. And I know that the vertical angles are congruent, so I'm going to go ahead and give those a single arc. And then I'm going to follow the, guess that these two longer ones are congruent, so I'm going to give them a single tick and a single tick. And then the angle, so a double arc right here and double arc right here. Then the one down here, the hypotenuse leg. So hypotenuse leg only works on a right triangle, so I'm going to draw in the little box on each of the two triangles to show that we have 90 degrees right here. These two triangles also share a side, so I'll put a single tick because they're congruent to itself or to each other. And then we also need the hypotenuse. So I'm going to put a double tick on the hypotenuse. All right, question number 8 says, are the triangles similar? And they want to know why. Okay, so we've got this triangle on the left and we've got this triangle on the right. The triangle on the left has a shorter side and a longer side. The triangle on the right has a shorter side and a longer side. So I'm going to set up a proportion, and I'm going to see if that proportion is true. If it is, then yes, they are congruent. If it's not true, then no, they're not congruent. So the triangle on the left, the shorter side is 2. And then if I hit return, I'm going to make a fraction. Oh, maybe I can use that. Let's hit return. I'm going to make a fraction out of it. And the shorter side on the right is 4. Then I'm going to see if these two triangles are equal. So the longer side on the left triangle is a 3. I'm going to make it into a fraction. The longer side on the right is 6. So my proportion is 2/4 is equal to 3/6. We're going to see if that's true. I'm going to do something called the cross product. That means I'm going to multiply from the numerator to the denominator this way and from the numerator to the denominator this way. So I'm going to multiply 2 times 6. See if that is equal to 3 times 4. And some of you have already finished that in your head. 2 times 6 is 12. 3 times 4 is also 12. So are they similar? Yes, they are. They have the same proportion. Okay. Are they congruent? Obviously not. No, they are not congruent, but are they similar? Yes, because their proportions are the same. All right, so for the next set of triangles, I've got some angle measurements inside of each triangle. So the triangle on the left, I've got an 88, a 48, and then this one isn't labeled. Well, we know by the Triangle Sum Theorem that if we start with 180 and we subtract the two angles that we know, we can figure out what the third angle is going to be. In this case, 180 minus 88 minus 48 is equal to 44. So the angle up here is 44. On the triangle on the right, we can also start with 180, subtract the two angles that we know, subtract the 48, subtract the 50, and that means that the leftover angle right here is 82. So do all three angles correspond to each other? Obviously not. So we're going to say no, these two triangles are not similar because they would have to be similar with all of the angle measurements. Okay? All right, and the third one has a triangle on the left and a triangle on the right. So I'm going to set up a proportion again and use the cross product to see if it's true. So I used the shortest measurement on the right triangle, which is 1.08, and I made a fraction out of it. And I said the shortest side over here, and I had to kind of look at them because it's turned, so I didn't know which one it was. It should be 2.48. Okay, we want to see if that's equal to the ratio of the longest sides. So in the numerator over here, I put the one on the right. So I have to put the longest side, and that would be this one, 1.28. I'm going to make it into a fraction, and the longest side over here is 2.63. Okay, so now I've got my proportion set up, and I'm going to see if it's true. So I'm going to take the 1.08, and I'm going to multiply it by 2.63. Then I'm going to multiply the other cross product, so that would be 1.28 times 2.48, parentheses there, and grab my calculator, and I get 2.8404 on the left, and I get 3.1744 on the right. And I say, that's obviously not the same. So, are they similar? No, they do not have the same ratio. So we say no, they are not similar triangles. All right, question number 9. Use the Pythagorean Theorem. This is a right triangle. I'm going to use X for this question mark right here. And I'm going to use my Pythagorean Theorem. Let's switch our color to purple. And our Pythagorean Theorem is a squared plus b squared equals c squared. And then we're going to plug in the two sides. And so the two sides that we know are the 4 and the 5. And they are what we call legs. Legs always plug in for the A and the B. The third side that we don't know is the longest side, obviously opposite what they're trying to say is the right angle here. So we'll call that one X. Okay, so we're going to have 4 squared plugged in for the first leg plus 5 squared plugged in for the other leg. We're going to set that equal to X squared, and then we're going to start to simplify. 4 squared is 16, 5 squared is 25, and we know that's equal to X squared. So I'm going to add the 16 and the 25 together. So my X squared is equal to 41. But that's not what x equals. We need the square root. So we're going to take the square root of 41. And when you do that on your calculator, you get this approximate number. So I'm going to say approximately 6.4. If you want to round to more decimals, you can. Okay. Question number 10 says set up a template for an equation. Okay, so what they want you to do is they want you to look at each of these figures and they want you to figure out what's going on. So this first one right here has a straight line, and then it's divided by a third, what should be a ray, to creating these two angles next to each other. So the first thing you need to know is that a straight line makes how many degrees? Well, it's half of a circle. A full circle is 360, so half of that would be 180. So this angle plus this angle is going to be equal to 180. So I'm going to call those angles x and y. Let's go green. Okay, so I'm going to say that x plus y equals 180 degrees. Okay. All right, let's look at this next figure. This next figure has two lines and they're cut by this transversal. We're going to assume that these two lines are supposed to be parallel. That would make angle A and angle B what we call corresponding. Corresponding angles are congruent. So we're going to say that angle A is congruent to angle B. And that's it. Okay, where can I move it to? Right up here. I'll move it above it. Okay. All right, this third drawing down here, we have these two angles intersecting, and these two angles end up being vertical angles, and vertical angles are always congruent. So I'm going to say, we'll call these angles, what do we want? GH. So we'll say that angle G is congruent to angle H, and we're good to go. All right, this last one, we have this triangle and the vertices are C, D, and E. They're wanting us to use something called the Triangle Sum Theorem, and we're going to say that these three angles add up to how many degrees? Hopefully you know. Angle C plus angle D plus angle E equals 180 degrees. All right. If you're turning this in through Kami, you're going to click Turn In here, then go to Schoology and click Submit. Have a great day. We'll see you later.